What is going on, guys? Welcome back to the channel. In this video, we'll be continuing the rational functions playlist by talking about rational expressions. So before we hop into the meat of the video, leave a like on this video, subscribe to the channel, and also comment down below any more topics you guys want me to cover in the near future. And also share the videos out to your friends and family that help us get more views on the channel. So let's hop right into it. So in a previous video, we said, okay, a rational function is in the form f of x is p over q, okay, where p and q are two polynomials. Okay, so two polynomials, meaning this is pretty much a division of two division statements. Okay. Well, we just want to focus on this piece p over q, and it's what we call a rational expression if we just look at this p over q. All right. In fact, you could take it even deeper and say it looks like a fraction. All right, so an example of this would be x cubed plus 2x plus 1 over x plus 2. That's a rational expression. But the question arises, all right, when we actually take this and we apply operations to it and add, subtract, multiply, divide, and even compose other functions, other expressions inside of this, how does it change? And when we look at functional values, we need to answer that question as well. So in this video, we'll be just going over pretty much skills that we need with it. Skills to develop the translations and how it affects. Well, all right, we're just going to be talking about the four operations, and then the next video, an application. All right, so we learned in the general functions playlist, if we apply any operations applied to functions, change the it would change the domain, range, and also the behavior. All right, we'll talk more about the behavior, the domain, and range of these functions once we finish. Once we actually go into talking about the functions. But so pretty much, all right. One thing we do need to establish is the denominator, x plus 2 cannot equal 0. All right. We'll use that for a future video, but pretty much, all right, so we're just going to be applying basic operations in this video. So we're going to be solving problems with these, and so, or solving, simplifying rational expressions when we add, subtract, multiply, divide. So pretty much, so the first example is adding, slash subtracting. Okay. The question is, all right, when you have two fractions, all right, so if you remember in the first or second grade when you started learning fractions, sorry guys, you guys can't see that. All right, when you guys have a fraction, all right, when you guys add two different fractions, how do we add them directly? Well, we need to have a common denominator, 1/3 plus 1/5. Well, we multiplied by factors that they each have in common. So we multiply by 5 over 5 and over 3 over 3. So that gives us 5 over 15 plus 3 over 15, which gives us 8 over 15. Well, same case for rational expressions, all right? So if we have 3 over x minus 1 plus x over x plus 2. Okay. How do we solve this rational equation? Or how do we simplify this rational expression? Well, we need to have common denominators, all right? And so we look to see what they have in common. So the LCD, okay, well, this one needs x plus 2 in the denominator, and this one needs x minus 1. So the denominator would be x minus 1, x plus 2. All right, so it comes out to be the product of the x minus 1 and x plus 2. Okay, so then we multiply each fraction by what it needs. So this is x plus 2, or x minus 1. All right, we just need x plus 2 in this case. Plus, and then we need, that's x, sorry about that, x over x plus 2, and we're going to multiply by x minus 1 on this one. Okay, so with that, we just say, okay, so we have, put them together, so 3 times x plus 2, over x minus 1, x plus 2, times x plus 2, plus x times x minus 1, over x minus 1. Well, okay, oops, you guys can't see that. Well, okay, now we just, so we put it together, now we could put the denominators together. Alright, so you could just, you could distribute, now we could add them. Alright, so now we just distribute each piece into each other, so that'll be 3x plus 6. Plus x squared minus x, all divided by, give me a second guys, put this down a little bit. It's going to be all, let me zoom in a little bit, sorry guys, all divided by, it's going to be all divided by x minus 1, x plus 2. All right, we leave, now we just leave the denominator alone. Take a new sheet of paper. Okay, so we had 3x plus 6 plus x squared minus x, all over x minus 1, x plus 2. Okay, so now we just combine like terms and we're finished. Okay, so both expressions in the numerator have x plus 2, or x is in common, so 3x minus x is 2x, so we have x squared plus 2x plus 6, all divided by x minus 1, x plus 2. Alright, I use parentheses to break this up because we really need to do that. Alright, well, guys, that will end the first part of this video. We'll talk to you guys in the next one later.